We can find limits when we're looking at a graph or if we have the composition of more than one function. Let's look at this graph example here. We have f of x, we have a parabola part, we have a constant function part, and then we have something with a vertical asymptote. So we want to find the limit of f of x as x approaches -2. We go over x is -2. We go down to the graph, and it looks like the y value is -10. So the limit of f of x as x approaches -2 is -10. How about limit of f of x as x approaches -1? Well, you go over to -1 and you might say, oh, it looks like it's close to 0. But wait a minute. We also, if you're coming from the left, you get -1, but if you're coming from the right, we get 5. Because we have two different answers, we have to say that it turns out that the limit here does not exist. How about the limit of f of x as x approaches 0? Here's x is 0. The y value is right here. Looks like a nice 5. And finally, how about if the limit of f of x as x approaches +2? Notice here's 2. Notice that the y value going from the right is a very, very large number. As a matter of fact, it doesn't exist. So again, we're going to say does not exist in this case. What happens if we go to composition of functions? We have a f function, f of x equals x plus 7, a g function, g of x equals x squared. Let's take the limit of f of x as x approaches -3. So we put -3 in for x, and we wind up with a grand total of 4. How about if we're interested in the limit of g of x as x approaches 4? So again, we put 4 in for x, so we wind up with 16. How about if we're interested in the limit of g of f of x? Now remember, when you compose functions, you do the inside first. So we have to take f of -3. To find f of -3, we put -3 in for f, -3 plus 7, so that gives us an answer of 4. So now we're going to take g, the limit of g of 4 as x approaches -3. So we're putting 4 in for x, gives us 16. So the grand total, the limit of g of f of x is equal to 16 as x approaches 3.